Sounds good. Alrighty. Well, good morning, everyone. And again, my name is Richard Stepanek. I work with Alpha Omega Institute. Alpha Omega is based in Grand Junction, Colorado. I don't know if you know where Grand Junction is, but you might know where Denver's at. You just go straight west over I-70. When you come out of the Rockies, you run into Grand Junction. We're just a few miles just before you get to Utah. And I used to live up in southwestern Minnesota. My background is agribusiness. I got an agribusiness degree and then went and started taking over the family farm. And I was a theistic evolutionist. You're probably wondering what or who is a theistic evolutionist? That is someone who believes that God used evolution to create the universe. I believed in the Big Bang, we came from monkeys, and the whole show, until I started studying true science. As a farmer, I should have known that evolution did not work. It did not take me long to reject evolution because with farmers, you know what we work with? Genetics. We got to know our genetics, otherwise we're out of business. So I raise livestock and we work with genetics. And when I was saved when I was 32 years old. That was in 1990. I became a creationist when I was 34. I went to an Alpha Omega Institute seminar, and they taught all this wonderful evidence that Genesis and creation is true. And so it didn't take me long to reject evolution, because I did work with livestock. We had mutations. I don't know if you're familiar with mutations. And, well, our livestock would have mutations, and guess what happened to livestock when they had mutations? They died. I knew instantly that evolution did not work, because according to evolution, you came here because of mutations. But I knew mutations didn't work scientifically. And also natural selection. Natural selection, you probably maybe heard of it. Natural selection is no friend to evolution. If you understand genetics and natural selection is devastating to the evolutionary philosophy. It does not work at all. And I teach on that because we work with something called, I like to talk about this before I get into astronomy, but I work with selective breeding, and what we did was select genetics. And we work with certain genetics, and with selective breeding, we want to eliminate the genes that don't work, and we want the genes that do work. Guess what natural selection does? It calls or eliminates the genes that don't work. So over time, things are less likely to change because of natural selection. I don't know if that makes sense, but what I want to get across is at every step of science, evolution does not work. And we're going to talk about astronomy here. And but if you want to know more about Alpha Omega Institute, you can go to our website at discovercreation.org. And if you can't remember that, I do have a business card back there and a prayer card. Please take them. They're free. And we also have sent out a free publication. It's free. Grab them. They're back there on the book table. And it has our website on there. And we do send this out. Just put your name and address on there's a sheet back there where you can put your name and address. We'll send that out to you free. So I'm going to get started. We're going to be talking about astronomy and the glory of God. Is there any way we can dim these lights up here, if that is possible? Because I look at myself in the mirror and I'm not so pretty. And I want you to focus on here. Okay, so now, there are only two choices how the universe got here. Only two choices. One is someone made the universe, or the universe made itself. Those are two choices. We're going to take a look at science. What does it support? Well, this is what I used to believe. This is what I was taught growing up through high school and college. I was taught there was no God. All the matter in the universe was in one spot. Some say it was the size of the egg. Some say it was really small, maybe the size of an atom. And then that egg or atom exploded, produced everything we see today. That's what I was taught, but that idea is beginning to change. This is in Discover magazine. Where did everything come from? Now, this is not some creation magazine. This is an evolutionary magazine. Where did everything come from? Well, they'll tell you. Take a close look at here. The universe burst into something from absolutely nothing, zero, nada. When I'm talking nothing, I am talking no time, no space, no matter. Absolutely nothing. And as it got bigger, it became filled with even more stuff that came from absolutely nowhere. What are you laughing at? People spend good money learning this, years studying this. And it is silly. It makes no sense. How, how is that possible? Ask Alan Guth. His theory of inflation helps explain everything. I don't think it explains anything. In other words, nothing did something to nothing to make everything. That's how you got here. Nothing created you. I teach this to little kids. Isn't that interesting? You know what they say? Rich, that can't happen. That's true. It can't happen. We know, because the problem is nothing is the first cause. Nothing has no intelligence, no power, no presence, but you came about by nothing. Nothing is the creator, but that violates the first law of thermodynamics. Because energy and matter cannot create nor destroy itself. Did you know that? I do a Genesis talk. I actually teach the whole book of Genesis. Did you know there's tremendous amount of science in the first chapter of Genesis? If Charles Darwin would have understood the scientific information in Genesis, he wouldn't have made the blunder he did on Galapagos Islands. Everything that he saw on Galapagos Islands was all predicted in Genesis chapter 1. It's all there. And if they would understand what was going on in Genesis chapter 1, they wouldn't have made the blunder of the Big Bang either, because it doesn't work. And we're going to take a look at that. So for evolution, nothing is the creator. Nothing's your creator. Wow. Okay. But with their nothing, there can be no time. So there are no billions of years for things to happen. I was always taught, given enough time, anything could happen. Well, if you have no time, can anything happen? No. And what happens over time? Do things get better or do things fall apart? I don't know about you, but my body's wearing out. The hair's going, the knees go. My hip is gone. I had to get a new one. I'm not getting better, people. I'm getting worse. That's a law of entropy. Science is directly against evolution. Well, then there's this singularity. After nothing gets something, we have the singularity as a very small point, hot, dense point. But basically in the beginning there was nothing, and then nothing exploded to produce everything we see today. Well, what do we know about, that's the Big Bang. Well, what do we know about a huge release of energy? Anybody who works in the military understands huge releases of energy does what? Destroy things. And the more energy that's released, the better the destruction. Isn't that correct? We know that. We know that through science. But the whole idea of the Big Bang is nothing new. Did you know that? Peter wrote about the Big Bang 2,000 years ago. But the day of the Lord will come as a thief in the night, in the which the heavens shall pass away with a great noise, and the elements shall melt with fervent heat. We take a look at the elements, the atoms will be so hot, they will go into subatomic particles. That's what Peter's talking about here. That is the Big Bang. And the earth also and the works that are therein shall be burned up. See, when we take a look at Scripture, God talks about the Big Bang. But he's not going to create things with a Big Bang. He's going to do what with a Big Bang? Destroy. What is more scientific? Big Bangs making things or Big Bangs destroying things? Well, so we take a look at this. The Big Bang hasn't happened. It's yet to come. And the bottom line is where are you going to spend eternity? That's the bottom line. Do you know everybody lives forever? Everybody does, both believers and unbelievers. They live forever. Because whatever God does lasts forever. But there are two places where people live for eternity. One is in the smoking section, the other one's in the non-smoking section. Where are you going to spend eternity? That is the bottom line, people. Then there was a Big Bang, and when the energy cooled, it would produce matter, but it would produce equal amounts of matter and antimatter. And you're probably thinking, what is antimatter? How many of you have ever seen Star Trek? USS Enterprise, what was that powered by? Antimatter. Using dilithium crystals. Yes, okay. If something goes wrong with the dilithium crystals, they're in trouble. Well, when antimatter comes into contact with matter, what happens? Huge release of energy. With the Big Bang, there should be equal amounts of matter and antimatter. But the problem is the universe is mostly matter, and it's a very good thing it's mostly matter, because if matter comes in contact with antimatter, guess what will probably happen to the universe? Blow up. Yeah. This is a major problem for the Big Bang because we have too much matter and hardly, if any, antimatter. Wow. And there's all kinds of problems. We go on and on. And then so as we take a look at this, we got a monopole problem. We got a horizon problem. We got a flat universe. There's problem after problem after problem with the Big Bang. But are you told this? No. Wow, that's brainwashing, isn't it? You bet. Is there a lot of brainwashing and culture, cancel culture going on today? Oh yeah, cancel culture has been going on for a long time, people. That's not some new phenomena. Yes, actually, if you want to understand cancel culture, you can go to Romans chapter 2 or Romans chapter 12. Be not conformed to this world. That is, and conform means cancel culture. You form the people to their worldly view. Well, so take a look at this. Now, as we go to the Big Bang. After that energy began to cool, it produced neutrons, electrons, and protons. And then this is supposed to come together, form hydrogen gas. And then this hydrogen gas came together through gravity. Through gravity was supposed to make galaxies. What's hydrogen gas? Well, if you look at the old dirigibles or those Hindenburg and so on, they were used hydrogen gas. And we know that's very flammable. The Hindenburg ended up blowing up. So basically, everything came from that first element, hydrogen gas. And then the hydrogen gas comes together to form stars and galaxies. What causes that to form? It says gravity pulled these molecules together to form stars and galaxies. And we're going to be talking about gas. Well, and then some of those stars aged and exploded. And then they made new stars. And then they aged and exploded. And then they made heavier elements. Then that dust and gas came together to form the Earth. This is the evolutionary scenario. I don't believe this. And then things began to evolve on this planet, and after about 13, 14 billion years, after the Big Bang, you came to be. Kind of complex. I'm going to simplify it. Simplify the whole idea. Now, students, hydrogen is a gas which is left long enough turns into people. That's a Big Bang. And that's not too far off. Do you know you're mostly made of hydrogen, oxygen, nitrogen, and carbon? What is that? Gas. You're mostly made up of gas. Did you know that? If you really break it down. Okay, well, yeah, we're made from the dust of the earth, elements of the earth. That is so true. So, again, everything came from gas. Well, but there's problems. The universe is extremely orderly. Extremely orderly. I was over in California. I talked to a guy that worked at NASA, and he made probes and worked with probes, sending probes into outer space to other planets. After the space shuttle exploded, they had to go from liquid fuel to solid rocket fuel. Solid rocket fuel doesn't have enough energy as much as the liquid rocket fuel. So when they sent a probe to Jupiter, they couldn't send a probe directly to Jupiter because they didn't have enough energy to get to Jupiter. So they sent the probe to the sun. Why are they sending it to the sun? Well, they ricocheted off the sun, and with that energy, they threw it over to Jupiter. It was a 5-year mission. They only had a 30-minute window. Because if they would have missed that 30-minute window, they would have missed Jupiter. Isn't that interesting? They had 29 minutes and 30 seconds of time to look at Jupiter. They missed it by just 30 seconds of being just perfect. On a 5-year mission. Isn't that interesting? Did they know exactly where Jupiter was? They knew exactly where Jupiter was because the whole universe acts as clockwork. Extremely orderly. Evolution is chaos. If evolution is true, we would never hit Jupiter because we wouldn't know for sure where it's at. Are you with me here? Somebody ordered this universe, and that's a big problem for the Big Bangers. So I don't know if you heard of a multi-universe. This universe is so impossible by chance and accident that it could not happen. That means they come up with multi-universe. There's an infinite amount of universes in the world. And this one just got it right. Okay? Is there any scientific evidence for this? Zero. It's all make-believe, people. And it goes on. Now, if there was a Big Bang, there should be an even distribution of matter throughout the universe, but instead it's lumpy. If the Big Bang should happen, this is basically what we should see with matter throughout the universe. Stars and everything should be kind of evenly distributed throughout the universe, but that's not what we find. This is what we find. We find lumpiness. We find clusters of galaxies and superclusters of galaxies, then nothing, empty space and another cluster, and then empty space and another cluster. Are you all with me? Good. Thank you. Another big problem with the Big Bang is chemistry wrong for the Big Bang in 20% of the stars. They're the missing population 3 stars. I don't know if you know what a population 3 star is. When the Big Bang happened, most of what was produced was hydrogen gas. A little bit of helium, a little bit of lithium, but the vast majority was helium gas. So when they look deeper into space, they should look deeper into time, back in time. Well, it doesn't work, but we won't go there. They should find some population 3 stars that happen or formed shortly after the Big Bang with only hydrogen in them. But they have never found a population 3 star because they always find heavier elements, metals, which means they were supposed to come from an explosion of a population 3 star, but they don't find them. This is big. There's problem after problem, people. But before the Big Bang, there was a steady state theory. I don't know if you remember the steady state theory. Basically, the universe was just like it is for eternity. But then they found out that this didn't fit because we have way too much hydrogen gas in the universe to have an eternal universe. So basically, they were teaching that hydrogen popped out of empty space. Come on, that violates the first. If you believe in evolution, you have to reject it. Science, did you know? That's why I became a creationist. Because I believe in science and the Bible. And science fits perfectly with the Bible. So this didn't work, so they came up with a Big Bang theory. Well, how did they come up with a Big Bang theory? Well, are you familiar with the Doppler effect? You are. I find people are more intelligent than they think they are. When I explain it, you'll say, oh yeah, I knew that all the time. Doppler effect is as something is approaching you, like a car or a train, and it's honking its horn or blowing its whistle, the sound waves are compressed. So there's a higher pitch. And as that train leaves you or that car leaves you, the sound waves are stretched, so it's a lower pitch. It goes, ee-oh. Okay, yeah, you got it all. You're smarter than you think you are. So, well, they were taking a look at the spectrum, and there's these Fraunhofer lines. As light passes through like helium, it absorbs certain wavelengths. And if you're lost, and your eyes are starting to glaze over, it probably won't get any better this morning. Okay. Alrighty. Now, if these Fraunhofer lines are pushed to the red side of the spectrum, that's where the wavelengths are longer. That means the object, according to this idea of redshifts, is flying away from us. If they're to the blue side of the spectrum, that means that object is coming towards us. That's the idea. So, they were looking at galaxies. Most of the galaxies have a redshift. So according to this idea, the galaxies are going where? Oh wait, good, you can talk to me. All righty, great. Now, the greater the redshift, the faster it's moving. And if it's moving faster, it should be further away from the Earth. Is that making sense? That's how they kind of get the distance when they get hundreds of millions of light years away and so on. Now, but the question is, one of the things is not all, it's like also like this. We're blowing up a balloon. You put all these stars on a balloon. And as you blow it up, what happens to the stars? They move away from each other, do they not? That's kind of the principle here. All of them should be moving away, but not all of them. There are some galaxies that have a blue shift. That means they're coming towards us. There could be a collision, but don't worry about it. They're so far away. But is there another idea that could make red shifts? I think there is. We take a look at Scripture. Thus saith God the Lord, He that created the heavens, and what did He do to the heavens? What would that do with light if you're stretching the heavens? Probably stretch light, give a red shift. Also, God made the stars. He did not create the stars, He made the stars. And I talk more about this in my Genesis talk. But God set them in the firmament. Which means God did not make the stars where we see them. Did you know that? Did you know God did not make the stars in outer space? He did not make the stars in outer space. He made them outside of our known universe and then moved them in. Setting, this word set means like setting the table. How many of you have ever set the table? When you set the table, are the plates already on the table? No, they're someplace else and then you set them on the table. That's what God's doing. So He's moving the stars into the universe and arranging them in an orderly fashion to what we have today. So if you are moving stars, what are you going to do with the red shifts? You're going to have some red and blue shifts. You're going to really mess with this stuff. So there's a whole other explanation about red shifts other than what we see from secular philosophy. Now, this is an interesting book. It's by Halton Arp. Now, Halton Arp is not a creationist. I disagree with some of his conclusion. But the information that he has is very interesting. Seeing red. He lost his job by what I'm going to teach you here. And he's not a creationist. He's an evolutionist. He's not a believer as far as I know. He did some studies on quasars and galaxies. As we get more technology, we can build better equipment so we can see more and more stuff in outer space. So Stefan's quintet, what it is a number of galaxies. There's about 5 galaxies. And as he looked at it, he discovered these galaxies are connected. Some matter from one galaxy is connected to the next one, so on. And so he was looking at redshifts. Now, going back to redshifts. If you have a greater redshift, that means you're moving faster. That's kind of like if we all lined up, there's a gym over there. If we all lined up on the starting line on the gym and someone says go and we all rush to the finish line, will we all get to the finish line at the same time? No, with this new hip, it is very difficult for me to run. Grandchildren can outrun me now. It's pretty hard to catch them. They have a big advantage. The ones who run faster will be further away from the starting point and get sooner down to the finish line. You all with me? Let's say we all hold hands. And someone says go, and we all run to the finish line. We will roughly get to the finish line all at the same time. Roughly. Some people might be dragging other people, but roughly at the same time. Now, so we should all have the same redshift if we're all holding hands. Doesn't that make sense? Well, he did some research and he discovered that some of these galaxies had a high redshift and other galaxies were connected, had a low redshift. Hundreds of these. This is just not unique. Here's another one, Einstein's cross. He got some quasars. We won't go into quasars. They were high redshift quasars connected to a low redshift galaxy. You can see where the material's connected. Go back here. You can see where the material's connected. And then we have another one here. He's got high redshift quasars connected to low redshift galaxies. Here's another one. 2 galaxies here. There's a low redshift. There's a high redshift. Connected. They can see the material. They're all connected. They're holding hands. They should all have the same redshift, shouldn't they? They're not being ripped apart. And here's another one. They took a look at this galaxy, and they discovered that the red areas here are a positive redshift. That means it's moving away. And the blue areas here are a negative redshift. That means it's coming towards us. So this galaxy is going away from us and towards us all at the same time. This guy come to the conclusion that redshifts have nothing to do with things moving away or coming towards us. Different sources of light give off different redshifts. He has debunked the Big Bang. He's rejected the Big Bang, and because he rejected the Big Bang and disproved the Big Bang, he lost his job. You don't go against evolution and get away with it, even if you're an evolutionist. Isn't that something? Because it has nothing to do with science. It's all politics, people. Yeah. Did you know the sun has a redshift? Depends on where you look at the sun, you get different redshifts. How many of you are concerned about global warming? Enjoy it while you can, people. If the sun's moving away, it's going to get pretty cold. Yeah. Isn't it interesting? Well, so there's another idea about what's causing redshifts. Yeah. And they also discovered that galaxies over time can change in redshifts. That means they speed up and then slow down and then speed up. Is that a problem? Yeah, that'd be a big problem. So it can go on and on. You know, they got problem after problem. Although the Big Bang Theory is widely accepted, it probably will never be proved. Consequently, leaving a number of tough unanswered questions. Yeah, there's a problem. There's a lot of problems. This one here I thought was pretty good. Scientific American, quantum gaps in the Big Bang Theory. Why our best explanation of how the universe evolved must be fixed or replaced. I think it needs to be replaced, because if it's replaced, it really eliminates a lot of problems. Did you know that? Yeah. So, what about stars? How did stars form? This is what I was taught in astronomy. I like science, so I took extra astronomy class or science classes. I was taught, well, after the Big Bang, hydrogen gas was produced. And so you had these clouds of hydrogen gas. And then the gravitational attraction of that hydrogen gas brought this nebula, this gas nebula, closer, and these gases came closer together and then start making blobs. And then more gas came together, and then more gas that came together, and you got bigger and bigger blobs of gas. And then in the middle there was friction. As the pressure increased of gravity, the friction increased. And what does friction cause? heat, and then it got tens of thousands of degrees. There was a nuclear reaction, and the star was born. That's what I was taught in astronomy class. Then you go to physics class. You know what they taught me in physics? Properties of gases, they fill the container that they're in. Just like the gas in this room does what? Clump up in little balls, or does it fall to the ground, or does it fill the container it's in? It fills the container that it's in, and it's a very good thing that it does fill the container that it's in, because if it clumped up in little balls, you know what we'd be doing? We'd be on our hands and knees sucking up these gas. Okay. Then there's gas pressure. This gas pressure is far stronger than the gravitational attraction force. So as we take a look at that, here's a truck. This is by Gillette, Wyoming, not too far from here. Here's my wife. This truck hauls coal. The truck empty weighs about 120 tons. Load capacity is 170 tons, so fully loaded is about 300 tons of weight. That's a lot of weight, isn't it? What do they put in these tires to keep them inflated? Air. Does air pressure have a lot of force? Yes, it does. And if you're, I don't want to scare you, but if you're in a plane flying at 33,000 feet, and that window goes out beside you, guess where you're going to go if your seatbelt isn't buckled? That gas pressure wants to go out because it wants to equalize. It'll take you right out the window. Isn't that interesting? And then when gas heat up, guess what happens to the gas pressure? It increases drastically. That's why it's so dangerous to throw an aerosol can in fire, because if you throw an aerosol can in fire, guess what will happen when that gas heats up? It will literally rip the metal apart. Now, when I was a kid, I was not very bright, and things have not changed a whole lot, but I don't do this anymore. These are those things you should not do. Okay? I like to see aerosol cans blow. It's cool, but don't do this, people. It's very dangerous. You're playing with a bomb. I would throw it in the burning barrel, run around the barn, watch the burning barrel, and then poof. Isn't that interesting? Don't do that, guys. Steam locomotives are all built on the pressure or on the principle of what? Expansion of what? Hot gas. We're dealing with water here. That water, liquid water, turns into water vapor, and there's so much pressure there, it can move tons and tons of weight. And I don't know about you, but I like to hunt. And I like to hunt elk. And I've got rheumatoid arthritis, so I don't eat domestic meat. It causes issues with my body, so elk is pretty good. And I've got this little 160, you hunters probably understand, I got this 168 grain bullet, and it comes out screaming out of that barrel about 3,000 feet per second. And I can kill elk at a half a mile. I've done it. What causes that bullet to scream out of that barrel? Expansion of hot gas, because there's a chemical reaction there. A lot of hot gas is produced, and that bullet comes screaming out. You know what it is like to make a star? This is one of those things you do not do. When you pull the trigger, that chemical reaction takes place in that cartridge, and that bullet starts to scream out of that barrel. That hot gas is building up. It's like taking that hot gas and going like this and compressing it till it sticks together. That's what it is like to make a star. What would happen to your gun if the end of the barrel was plugged up? That hot gas would do what to that barrel? Rip it up. There's no way a star can make itself, people. Not according to physics. Don't tell me. Oh, wrong button. There we go. Mount St. Helens. We're going to talk about Mount St. Helens this afternoon. That's Mount St. Helens. Before it erupted in the spring of 1980, then there's Spirit Lake in the background. Mount St. Helens took up a very bad habit in the spring of 1980 and began to smoke. Shortly after beginning to smoke, it erupted. Here's a projectile. This projectile is about the size, it's a boulder about the size of this room. Isn't that something? That's a lot of force. What caused that mountain to blow up? It was caused by an explosion of superheated liquid water, flashed into steam, and blew at the top off. About 3/4 of a cubic mile of material came off the top of that mountain. That explosion was like 20,000 Hiroshima-sized bombs taking place. That's the expansion of hot gas. Can stars make themselves? No way. Not according to science. Someone had to make them. So, we'll talk more about that, but what's interesting is these nebulas, these are supposed to be gas and dust clouds out there. The gas in these nebulas are about 25,000 trillion times as thin as our Earth's air in our atmosphere. Isn't that something? That's not very dense, is it? But even so, what's supposed to make these things is the gravitational attraction. The gravity to make parts of the nebula shrink into blobs. What are you talking about here? Did you know when you take a look at the Earth, you know hydrogen is escaping from our atmosphere? There's not enough gravity of the Earth to keep hydrogen in, so how is hydrogen at 25,000 trillion times thinner than our atmosphere supposed to come together? You know what that hydrogen wants to do in the atmosphere or out in space? Fill space. And they know it. A lot of problems to make stars. As material comes together, it starts to spin and flatten out. This is called angular momentum. You all understand angular momentum, don't you? Oh, yeah, you do. You're more intelligent than you think you are. When I explain it, you'll say, oh man, Rich, I knew that all the time. But we'll get to that. We're not going to explain it right now. As this stuff starts to spin, you know what force is built up? Centrifugal force. Things want to push out. So a star can't form because of angular momentum and centrifugal force. Also, when things start to spin like that, it produces a magnetic field. You know what the magnetic field would do? Prevent the gas from collapsing. We've got scientific information that stars can't form. So if someone tells you that gravity makes stars, don't believe it because that's not scientific correct at all. So somebody made all the stars. And here's a quote. There's about 10 to the 22nd stars all told, and we do not know how even a single one of those stars managed to form. There's all kinds of ideas, but none of them fit with science. The process by which an interstellar cloud, that's a nebula, is concentrated until it is held together gravitationally to become a protostar is not what? For it to be scientific, it has to be what? At least observational, right? Yeah. If stars that exist, it would be easy to prove that this is what we expect. So according to science, there shouldn't be any stars out there. But there is. Why? Oh, I'll jump over this. There's all kinds of stuff against the whole star formation, but no one has actually watched a nebular cloud coming together form an embryonic star. That has not been seen. What we do see is, guess what these nebula clouds are doing? They're not coming together, they're doing what? They're breaking apart. Yeah. And that fits in right with what we see with physics and science. The complete birth of a star has never been observed. Not at all. I've never seen a star born. But this is supposed to be the stellar evolution. This is what I was taught. You start with this nebula cloud. The gases come together to form a star, protostar, and then it goes through this main sequence. The sun's about right here in this main sequence. This is the aging of a star. Then if it's a really big star, it turns into a red giant or supergiant, and then it goes into, if it gets really old, it's supernovas. That's basically a star explodes, sort of. And if it has a lot of mass, it will go into a black hole. If it's not quite as big, it goes into a neutron star. Our star is not a super big star, has a low mass. So as it gets older, it should turn to a white dwarf or a black dwarf. Basically, what we're looking at here, these are just, according to evolution, these are just grandpa stars, great-grandpa stars. These are just baby stars. Are you with me so far? Has anyone ever observed all this? No. There's no scientific evidence for it. It's all inferred. It's just their guesswork. That's what they think. But we take a look at Corinthians, 1 Corinthians. Paul writes, there is one glory of the sun and another glory of the moon and another glory of the stars, for one star differs from another star in glory. You know what Paul is telling us? All the stars are what? Different. That means we got all kinds of different stars in the universe. And you know what they have now discovered? Stars are very complex. There's no two stars exactly the same. How did Paul know all this scientific information? We just recently discovered it. He knew about it 2,000 years ago. You know what scientists should be doing? Reading their Bibles. So God already said that the stars are all different. So we got white dwarfs, we got yellow stars, we got blue stars. Now, blue stars are not cold stars, by the way. Blue stars are really hot stars. Red stars are cool stars. It's just the opposite. Blue is hot, red is cold. Okay. And then there's the red giants and there's the dwarf red stars. Do we have all kinds of stars in the universe? Yes. Guess what? Paul predicted this 2,000 years ago. One is not aging to another one. Wow. We just got a lot of different stars. Amazing. This is all false. This is interesting. This is a supernova. When the star went into supernova, there should be evidence of a neutron or maybe a black hole, but there's no evidence of a neutron black hole, so their idea of this, there's something faulty with their philosophy. Here's a nebula. Basically, according to evolution, this is a nursery. This is a star nursery. And when you go to the hospital and you go to a nursery, what would you expect to find in the crib in a nursery? A baby. But what happens if you go to the nursery and instead of finding a newborn baby, you find grandpa in the crib? Would that be a problem? Big problem. And that's what they find. Here's one of those nebulas here, and here they found a neutron star. That's supposed to be great-great-grandpa. He's in the crib. So that's supposed to be there. How did he get there? Oh, he migrated there. You know, got all these other stars there. Did they migrate in too? They just didn't like that one, so they had to come up with an idea to try to explain it away. Isn't that interesting? Yeah. And stars, some stars can change. This is in Egyptian hieroglyphics. This is Sirius. They reported it was a red star. And then Cicero came about 50 BC, said Sirius was a red star. And then Seneca described Sirius as a redder than Mars, so it was a red star. But the problem, Ptolemy listed Sirius as a red star, 150 AD. But the thing of it is, today that star is a white star binary. It changed in a very short time. Here's another star. This one here, this was in New Science in September 14, 1991. They reported a blue star changed into a yellow star in 36 years. Interesting. A lot of interesting things out there. So, now this is the Deep Field Telescope. It looked like as it's looking at the stars, the universe lights, that's the stars, contrary to astronomers' hunch, turned on in one great burst. Isn't that interesting? It looked like somebody just flicked the switch and all the lights in a castle or mansion went on all at the same time. What day did God make the stars? Day 4. Basically, he did the switch and they came on. Well, let's take a look at the solar system. How did the solar system come to be? This is what I was taught. Today, most astronomers believe. When I read these scientific journals on evolution, I look for words like believe, we think, maybe. Those are pretty scientific terms, aren't they? I like to read those and they say, well, we think this happened, or we believe this happened, or, yeah. Where's the observational evidence? Well, and so what they taught is you got this nebula of gas and dust from a star that exploded, and from a star that exploded, and from probably another star that exploded. So we're looking after a few stars that have exploded to get the dust and the heavier metal. As the gravity pulls it together, it begins to flatten out and spin. And as more and more material comes to the center, the rotation of that ball in the center increases drastically. This is what we call angular momentum. Now, you all understand angular momentum. I'm going to explain angular momentum in a little bit. Here's the sun. We take a look at the sun. Some of the information of the sun, it has about more than 99.8% of the solar system's mass. So most of the mass of our solar system is in that sun. It rotates once about every month, which means it's moving very, very slowly. Our Earth rotates in about 24 hours. It contains less than 2% of the angular momentum of the solar system. But if it has most of the mass in the center, it should have most of the what? Angular momentum. Well, what's angular momentum? Are you familiar with figure skaters? This is our daughter. She took up figure skating. When she is spinning and her hands are out, what is the speed of her rotation? Slow. When she brings her arms to her center of her body, what happens to her spin? Increases. So as more mass comes to the center, this rotation increases. If she wants to stop, you know what she has to do? If she's trying to stop like this, you know what's going to happen? That's angular momentum. You all understand that, right? Yeah, you guys are smarter than you think you are. Well, here we're going to take a look at the solar system. Again, sun, most of the mass, very little angular momentum. The planets have very little mass. They have most of the angular momentum. Is this a problem for the formation of the solar system, according to physics? Huge problem. They know it. Angular momentum is a huge problem. Planet formation is another big problem because things are moving very rapidly in outer space. Have you ever seen that movie Gravity? I think that was called, I don't know if you've seen the movie Gravity. It had a space shuttle out in space. Some other satellite broke up or got hit, and all these particles, they hit the space shuttle. And what happened when all these particles start hitting the space shuttle? Anybody remember? Start breaking apart. I mean, things are flying at an incredible speed out there. Little particles can do a lot of damage to our satellites and things out there. Just little dust particles. And when you see a shooting star, mostly, you know what that is? That's a dust particle traveling so fast when it hits Earth's atmosphere, there's so much friction, it burns up and produces a light. Things are moving fast. Basically, the problem is if you have all this dust trying to come together to make the planet Earth, and a little dust particle comes screaming and hits that dust ball, guess what's going to happen to the dust ball? Poof. How many of you have ever played pool? You got all those balls there in a nice triangle. You have a cue ball here, and you're going to hit that. You're going to hit all those balls. You want to put them in the pocket, so you hit that cue ball, and it hits one of those cue ball or one of those balls, and that gravitational attraction all sticks together. And when one ball goes in the pocket, all that other balls go. Oh, that's not what happens? Oh, it doesn't happen. It should happen if this is correct. Because when that big thing, that little speck of dust hits that, all that should just stick together and hold it together. But no, it does. It goes like this. Yeah, you can demonstrate physics right playing pool. Yeah. But it's not entirely clear how a bunch of pebbles manage to collide, stick together, and form kilometer-wide planetesimals, basically the great big dirt balls, as Ward describes them, that are the progenitors of planets. How planets got here, they don't have a clue. But we're going to take a look at planets and stars. These are the rocky planets. They're all to scale with one another. Pluto was a planet, then it got kicked out as a planet. As far as I know now, it's back in the planet. I always liked Pluto. Do you know Pluto it's got 5 moons? I don't know how Pluto rates. We got 1, he's got 5. I think we should complain. Now, here's India right here, and Casper, Wyoming is right on the other side of India. So, in your mind, picture where you're on that round ball, because we're going to compare the rocky planets to the gas planets. They're all to scale. So you're on the other side of this round ball. Now we're going to compare the planets to the sun. There's the Earth. Can you still picture where you're on that Earth, or that dot? Yeah, you're on the opposite side. Now we're going to compare the sun with stars in our galaxy. There's the sun, there's Jupiter, and if you can see the Earth, you got better eyes than I do. There's Arcturus. Now, Arcturus is not the biggest star in our galaxy. There's Arcturus. That was the big star in the last picture. There's our sun right there. There's Antares. Now, Antares is not the biggest star that we know of in our galaxy. Now, that was the big star in the last picture. There's Canis Majoris. That is the biggest star that we know of so far in our galaxy. Canis Majoris means big dog star. Is it a big star? It's huge. This is our sun next to Canis Majoris. Canis Majoris is about the size of Saturn's orbit around the sun. Is that a big star? According to what we know about physics, somebody had to take that gas and compress it, heating up, pushing out, compress it, heating up, pushing out, keep compressing it so those molecules are so close together that they stick together and there's a nuclear reaction taking place, but they still stick together. Are we talking power here? You haven't seen anything for power. We're just getting started. I will show you power that I can't understand. Here we have a picture of a galaxy. There's about 100 to 200 billion stars in every galaxy. That's a lot of stars. This is a picture taken by the Hubble Space Telescope. This picture of outer space is about the size of a dime, a hand's length from your eye. That's all it is. That's not a lot of space we're looking at, are we? In this picture, there are only 2 stars. There's a star there, there's a star there. Guess what all these other white dots are? Galaxies. All galaxies, even these faint ones, galaxies. It's like that throughout the whole universe. According to science, every one of those stars had to be made. And according to the Bible, every one of those stars had to be set in their place. Are we talking power here? You don't mess with a person who has this much power, people. You will not win. It is impossible. When he says something, you know what I say? Yeah, whatever you say. You're like, I'm not going to argue. You don't tell this guy that he's wrong. Only a fool does that. He's going to get the last word. But what's interesting, our Milky Way galaxy is only a speck of dust in the universe. It's only a speck of dust. Our solar system was just a speck of dust in the Milky Way galaxy. The sun is only a speck of dust in our solar system. The solar system's huge. And there's a speck of dust orbiting the sun, that's the Earth. And on this speck of dust of the Earth, there's lots of specks of dust, and that's us. How many of you are feeling really big at this time? If this doesn't humble you, I don't know what does. And I'd like to get to day 6. When I teach on day 6, I show the complexity of the human body. Whoever made you went to a lot of work to make you. I like to teach this to teenagers, because you know what I like to do to teenagers' brains? Blow them. When I take a look at the chemistry that makes a teenager, they say there's no way I came about by chance and accident. There's no way. Somebody made me. Because did you know the average adult, I know I'm not going to get through my astronomy program, so I'm just going on a rabbit trail here, because I think this information's cool. The average adult has about 60 trillion cells. That's about 3 times the national debt. Okay, just to put it in perspective. That's a lot of cells. We're having did you know you have 10 million chemical reactions taking place per cell per second? For you math students, figure that out. That means somebody went to a lot of work to make you. If they went to a lot of work to make you, don't you think he wants a relationship with you? Don't you think he loves you? He loves you. When I teach on Genesis chapter 3, I will show you love that I can't understand. I can show you power that I can't understand, and I can show you intelligence that I can't understand. Isn't that interesting? God is dying to have a relationship with each and every one of us. He really is. So we're going to go back to the solar system. Because God has a good sense of humor. Did you know that? I'll show you some humor. Here's we have the solar system. Here we have the sun. And with the whole angular momentum concept, and if this is rotating around, came from a nebular cloud, this should be rotating on its axis the same way. These planets should all be orbiting the sun all the same way, and all the planets should be rotating on their axis the same way. Is that making sense? According to angular momentum. So if things are spinning like this, your cloud is beginning to spin and flatten out, everything should be going and spinning the same way. And I could explain that through, you're familiar with this device. What do they call that, a merry-go-round, is that correct? It's been a long time since I've been on one of those. Okay, so you get some guys and you get some kids on there, you start spinning them. So everything's spinning this way. This area here is moving faster than this, right? Right, because this has got to cover a lot more ground. This has to just go like this has to go all the way around. So as things begin to spin, well, let's go back here. Your legs are actually moving faster than where your arms are at. So if you get spinning fast enough and you can't hang on anymore, you know what's going to happen to your body? It is going to start rotating. Did you know that? You're going to go like this, and you're going to go spin like this as you go around. We can demonstrate that. If we can do that, let's go to the park, and I'll start spinning it. We'll see what happens. Okay, but we won't do that. So what's interesting is Earth and the planets go around and orbit the sun in a retrograde orbit. That's kind of like stick up your thumb, that's the sun. Curve your fingers, you stick up your right thumb, that's kind of the way we're going around the sun. And that's the way Earth rotates on its axis. It's got a prograde rotation, it goes this way. What's interesting is Venus is a rebel. It goes this way on its axis. Has a retrograde rotation on its axis. Isn't that interesting? That's the way it shouldn't be. What's interesting is Mars, one of the moons, has a retrograde orbit. Jupiter has about 4 moons that has a retrograde orbit. Saturn has 1 moon that has retrograde. Uranus, man, that guy couldn't get anything right. And then Neptune has 1, and Pluto, he looks like he's got issues too. So that's interesting. And so Phoebe, that's one of the moons of Saturn, has a prograde rotation orbit around Saturn, but has a retrograde rotation on its axis. It orbits this way, but it rotates that way. Then we have the Earth. Earth is interesting. It has a special relationship with the moon. Now, there's a gravitational attraction here between the moon and the Earth. What they've discovered is the moon moves away from the Earth about 1.5 inches per year. It's just that's not a lot when you're talking 240,000 miles. So it's drifting away very slowly, which means if it's drifting away from the Earth very slowly, that means in the past it must have been what? Closer. Is that making sense? It does to me. So it must have been closer in the past. Well, one thing with the inverse square law, I like laws of science, and because they work. English is another story. You know, when 1 + 1 always equals what? 2. But there's too many exceptions. Thank you. There's too many exceptions to the rules when it comes to English. See, I think very logically, and when it doesn't fit to the rules, I break down mentally. Okay, it doesn't work. So if you decrease the distance between two objects to 1/3, the gravitational attraction doesn't increase 3 times. The gravitational attraction increases 9 times. It's an exponential increase in a force. So as the Earth rotates, and with the gravitational attraction of the moon, it causes tidal wave actions. So the Earth rotates on its axis, and so twice a day you have a high tide and a low tide because of the rotation of the Earth. You all with me here? Okay, so as the moon gets closer to the Earth, what would happen to the tidal wave action of the Earth? It would increase. If it got so close, the tidal wave action would be so strong that you would have to tread water twice a day because Casper would be covered with water coming from the ocean. Isn't that interesting? And if it got close enough, the gravitational attraction of the moon would literally break up, or the gravitational attraction of the Earth would literally break up the moon. Yeah, isn't that interesting? So, we'll talk about that. That's the Roche limit. Because if it crosses what I call the no moon zone line, this is what I call the no moon zone line. If that moon crosses that line, bad things will happen to the Earth and to the moon. Yeah. So as we take a look at this, 6,000 years ago, I believe the universe is about 6,000 years old, the moon would be about 800 feet closer to the Earth. That's not a big deal when you're talking 240,000 miles. But if you go back 1.2 billion years ago, the moon would actually be touching the Earth. Would that be a problem? Slight problem. And as we take a look at this, the Earth's rotation is slowing down about 1.5 milliseconds for every 100 years. Because of the gravitational attraction of the moon and the Earth, what the moon wants to do to the Earth is, whoa, Earth, and the Earth wants to say, get up, moon. So there's this tidal wave action, gravity, the struggle. So it's actually the Earth's rotation is slowing. So in about 140 million years, the Earth would lose about 1 hour of rotation. So 140 million years ago, it was a 23-hour day instead of a 24-hour day. Now, if you go back 3.2 million years ago, the rotation of the Earth would take about 1 hour. You got 30 minutes of daylight, 30 minutes of night. So sleep really quickly because in 30 minutes, you're going to wake up and get back to work. But before you get your shoes on, it's time to go to bed. Isn't that interesting? Is he some problems? Wow. And Mars, I'm going to jump over some. Mars is interesting. These are some asteroids in the asteroid belt. What's interesting with these asteroids is some asteroids have moons. We got asteroid moons that orbit asteroids. Yeah. And then we have Saturn. Saturn has this ring. Basically, it's made of water and dust particles. Saturn has a lot of moons. Some are interesting, like these here. These 2 moons here actually have moons. So these moons orbit these moons, which these moons orbit Saturn. But and here's one of Saturn's moon called Mimas or Mimas, depends on how you pronounce it. What does that look like? Death Star. Yeah, interesting. Okay, alrighty. These 2 moons are cool. These 2 moons in Saturn's orbit, I kind of wanted to show these moons. But these 2 moons, they orbit Saturn. Those moons, their orbits are so close together that they could not pass each other. Because if they would try to pass each other, they would literally hit each other. That's how close their orbits are. So what happens is the lower moon's orbit in 4 years will pick up or catch up to the outer moon's orbit in 4 years. But remember, they can't pass each other, because if they try to pass each other, they will literally hit each other. But you know what they do? They do a little dance. They change orbits before they collide. This is what happens. As they're going around Saturn, in 4 years, the inside moon catches up to the outside moon, and before they collide, they change orbits, and they go around for another 4 years, and then they do another dance. God must have had fun on this one. How did that one get started? What's gravitational attraction supposed to do? Pull things to what? In this case, it doesn't, because you got the gravitational attraction of Saturn working with these moons, and all this gravity is working together, and it's all working just right, so they just do a little dance. I think the Trinity got up together. Let's show them something, guys. Woo. I was never taught this in astronomy. Isn't that interesting? Why didn't they teach me this in astronomy? No. This Saturn, one of Saturn's moon, Enceladus, how it depends on how you want to pronounce it. One side of the moon has a lot of craters, the other side has very little craters. So I was always taught in astronomy class, when you have a moon with a lot of craters, that means it must be a very old moon. If you have a moon that has very few craters, that must be a younger moon. So what is the age of this moon? Is he old or is he young? Middle-aged? This one has one of those midlife crises, I think. I don't know. It's just funny. There's just a lot of funny things. And then there's Pluto. You know, again, there's 3 of the moons. It actually has 5 moons. And comets are interesting. I was always taught that a comet was basically a dirty snowball. But then they sent a probe to one of the comets. They found out it wasn't a dirty snowball. It turned out to be an icy dirt ball. And I was taught that it was supposed to be a conglomerate. What's a conglomerate? Making mud and sand and silt and rocks and gravel all together, so it's all a mixture. Well, that's not what they found. They found an onion, had layers upon layers. Interesting. How do you explain that? If you understand Genesis chapter 1 explains exactly why you see that. I believe to truly understand astronomy, you got to get Genesis chapter 1 down. Because you got to know how God created these objects. That's why I like to read these scientific journals about astronomy. They always come up, well, we thought this, but this was completely had to change their idea about what we thought. They're always changing their idea. If they had it right the first time, they wouldn't have to change their idea. They would have got it right the first time. What's interesting is only the barest storyline of how comets form. They want to go out and find out how these comets form. We simply don't have any idea. They don't have any idea how these things formed. If we gave theorists the recipe, they can tell us how planet formation happens, and that's a what? A giant step. Yeah. Why are they studying comets? They're trying to study comets to find out how life evolved on this planet. Did you know that? They're trying to study the chemistry that made life possible on this planet. Do you know, according to science, we know that life cannot evolve on this planet by chance and accident? So you know how life got here? Outer space. Well, I can tell them how life got here, because I can tell them scientifically how life did not get here. According to science, you shouldn't be here. According to science, none of us should be here today. Did you know that, according to science? So why are you here? Your mom made you come, right? Is that why you're here? No, that's not what we're talking about here. According to science, you shouldn't be here because according to science, life cannot evolve from dead things. It's impossible. It will not happen. I can show you in chemistry, it will not happen. There's no chance of it ever happening. It's impossible. You heard of life evolving by chance and accident? That's a false scientific statement because it won't happen. Which means I know scientifically you're here because someone made you. And I hope you want a close relationship with that person who made you because he is wonderful. Once you understand who God is, I am totally confident you will trust him as your Savior if you truly understand who he is. Because once you find out who he really is, you cannot help but fall in love with the creator of the universe. You cannot. He's got power and intelligence and love that I can't understand, and he is a God of humor. Now, so let's close in prayer. Dear Father, we thank you for this day. We thank you for the blessings that you give us, Lord. We thank you for just being here. We thank you for science. As we study science, it gives us more information of who you are, but we really understand who you are is through your word. You explain the love that you have for all mankind, that you died for each and every one of us, and you sent your son, Jesus Christ, to die in our place. So those who believe will spend eternity in heaven with you. And I pray that each and every one of us has trusted Jesus as their Lord and Savior. In Jesus' name we pray, amen.